In this video, we'll learn how to analyse the results of a Gage R&R study using the Data Analysis Toolkit. I've seen many Gage R&R studies that have provided false results, and so we're going to be showing you the different features that have been included in this toolkit to help you to check that your study is genuinely representative of the process that you have for your measurements. Here's the Gage R&R worksheet itself. The data entry is fairly straightforward in that you have one column for the part, one column for the appraiser and one column for the measurement data. But in many companies they're used to an Excel template that has a table type layout, and we've provided that as an alternative. If you click this blue button, it takes you to the table layout and you can enter your data here with the 3 repeats for each of the appraisers and the 10 part numbers laid out in a format that is very popular. Now this is only going to be active if the column format that we have here is empty. So as this one's populated, this is the data that the toolkit's going to analyse. This is for a gap measurement with some kind of a feeler gauge, and we have a lower specification limit of 0 and an upper specification limit of 1.5 millimeters. And once I've typed the specification limits in, then you're going to see that the chart here changes. The blue bars show the precision to tolerance calculations, while the green bars show the percentage of study variation. Now, one feature of the toolkit to help make it easier to get the results right is the opportunity to enter the process standard deviation. This is the standard deviation of the parts as they normally come off through the inspection process. So if I type in here, shall we say that's 0.2, then what it will do is it will calculate the Gage R&R statistics. I've got a slightly different result there. The statistics are calculated based on this data, which is likely to be far more representative than the parts in the study, which is the traditional way of doing these analyses. But anyway, for today's purposes, I'm going to leave that out so that we can see the effect of problems with part selection. Okay, so looking at the graphs, the second graph here is also a summary of the overall process. We have the 10 parts listed in the order that they appear, so that's not actually in ascending order, and you can see the means are connected by this line so that you can see the part-to-part variation, and the box plots show the variation of the measurements within each part. And one nice feature we have in here is that it shows as well the specification limits. The lines are in green to avoid confusion with control limits, and of course you can't see the lower spec limit because it's 0, so it's on the axis. And the idea of this is to make it obvious if someone's put in parts that are close to or even outside the specification limit, which you really shouldn't do, because the intention with a Gage R&R study is that the parts are representative of the ongoing process. So looking at the next graph, this is an R chart by operator, and it shows the difference for each part, for each operator, the difference between the smallest and largest measurements that they made of that part. So this 0 here, for instance, shows that this appraiser got exactly the same results for each part. And then here we have a difference of 0.05 and a difference of 0.1. The goal of this particular graph is to enable you to see if you've got perhaps one operator who has significantly better or worse repeatability than the other two, or to see if there's any special causes in there, perhaps a mistaken reading, written down incorrectly, and if that happens, then you might get a big jump in the repeatability measures that takes you through the upper control limit, and that's a signal that there's a special cause, that something's gone wrong with the study. So that's the graph for repeatability. Over here we have reproducibility, and first of all this is the operator to operator reproducibility. We're looking to see the overall average for each operator being the same, which it clearly isn't. Operator 2 is reading noticeably lower than 1 and 3, so that gives us something to investigate. And below we have the operator part interaction. And here you're looking to see if the lines are roughly parallel. Well, they're not bad here. There's a little bit of a problem here. But what really you're looking for is something that's more dramatic than this, that might indicate that the study has been messed up. For instance, parts have been transposed in some way. Then this graph, the histogram of part averages, is an unusual histogram in that there's only 10 data points in it, one for the overall average of each of the 10 parts in the study. If the parts have been properly selected randomly from the process, then it should be at least vaguely normally distributed. And you get a warning message here if, as is the case with this one, that the distribution of the parts looks like it's not random and therefore is potentially suggesting that someone has manipulated the part selection, which can be done to game the Gage R&R study. Scrolling over here, we have the statistical analysis. This isn't intended to be a training course on Gage R&R, so I shan't cover it in any great detail, but I will point out that here is the Gage R&R figure, in this case 32.66%. That's the percentage of study variation, and you can see there the repeatability and reproducibility components. And here is the precision to tolerance figure. The coloured highlighting helps guide you as to whether you have a successful result or not, together with a little smiley face to make it even more obvious. And so in this case it's red, it's a frowny face because it's above 30%. And there's an additional warning message to let you know that the parts look like they have not been selected randomly, which might mean that the results are actually being misrepresented here. Finally, we have a gauge run chart, which is a visual representation of all the individual measurements of the 10 parts by the 3 operators and the repeated measurements that they've taken. So that's the Gage R&R study. There's lots of additional features in here above what you normally have to help you to see if the study's been conducted incorrectly. And I'll be looking at measurement systems analysis for attribute data in the next video.